Hi, students. It's Mrs. Dixon. I am talking to you today about using a table to help you figure out a pattern when it comes to input output charts and rules and algebra. So let me go ahead and show you my notes. This is what I have. And I want to go over the learning targets for today. The learning targets for today are I can create an input output chart from a numerical pattern. And then the other learning target I want you to think about is I can create a numerical expression and rule using an input output chart. So those are the two skills that we're going to work on today, and our notes are going to be very focused on those specific skills. So remember what I've said every single video that I've made. You can pause this video at any time. You can re-listen to any part of the video to help you with a skill that you might be confused about. Also, you can monitor your own understanding and you can use your own preferences. So if you like writing all the notes and then watching the video, you could do that. If you like watching the video, pausing, writing, watching, pausing, writing, you can do that. Or you could watch the whole video and then write the notes at the end. That is going to be your choice. Let's go ahead and get started. Not that video, this video. So here we go. So in your mind, you could ask yourself, how do you compare the towers? In my mind, I'm thinking that each story is going up by one. So like the pattern looks like there's one story, then two stories, then three stories. So if I go look at my notes, you'll notice that I said the topic, which is make a table and look for a pattern. I have terms and notes. And the first term I listed was pattern, and then the second term I listed was table. In that first video, that's pretty much what they talked about. And so I drew the towers, and I drew one-story tower, two-story tower, and three-story tower. And then I also labeled the story and the blocks, like they did in the video. So you would want to write that down so that you have an example of what a problem with a pattern looks like that you can refer back to. Let's go ahead and move on to the second activity. Let's go ahead and try this activity. The cool thing about it is it slides down so you can see the building of the tower. So if I slide this, it builds the tower. So I'm going to move it to back a little bit. And notice that the numbers fill in. One story has 4 blocks. And notice that they built a numerical expression that represents the rule, basically, 1 times 4. Then when we go to the next block, we have 2 stories, which results in 8 blocks. And the numerical expression is 2 times 4. Then if we slide on and put another one on, we have 3 stories. Our numerical expression is 3 times 4, which equals 12 for the number of blocks. Then, if I go ahead and just show you the rest of this, notice that 4 stories, 4 times 4 is 16, and 5 stories is 5 times 4, which is 20. So if I look back at my notes, you will see that I've drawn that table in my notes. A little different, I know it might be a little bit hard to read, but I wrote number of stories, and then I put the word input, and I wrote 1, 2, 3, 4, 5. Then I wrote the word numerical expression. A numerical expression is a number, operation, number. The difference between an expression and an equation is that an expression does not have an equal sign. It just has numbers and operations. An equation has numbers, operations, and an equal sign. So notice I put in 2 times 4, 3 times 4, 4 times 4, 5 times 4. And then finally, my third row, I wrote number of blocks, which is output, 4, 8, 12, 16, and 20. And then below, I did draw a representation of the stories growing. So you would want to do that too, so that you have this in your notebook to refer back to. Remember, at any time, you can pause this video. Let's move on to the next part of the video. And if you remember, in the notebook, we already built the tower, and we built a tower of 4 blocks with 4 rows. Well, you can count and see that it's 4. And this 1, 2, 3, 4. And we can easily make a numerical expression, 4 times 4, and we get 16. Well, as you saw, we could build a numerical expression, 4 or 5 times 4, and we would get 20. So 5 is the input, our rule is times 4, and that is why it's 20. One of the ways that a table helps is it organizes the data so that you can see it more clearly. So you can see that 1, 2, 3, 4, 5, and you can on the stories, but then when you look at the bottom row, you can see how it's growing. It's an increasing pattern, which we know is either adding or multiplying, but it's not just increasing by a set amount. And when it's growing in a way like by multiples, then it's going to be multiplication. I know what you're thinking. You're thinking you would write a numerical expression, and that is what I would do too. Okay, I'm going to stop the video here because I want to show you in my notes. I went ahead and did that, and I wrote it down in 10 stories. I wrote the expression, numerical expression, 10 times 4. I want you to solve that and find out what the output would be. And if it was 100 stories, I did the hard part. I wrote the numerical expression, 100 times 4. You can solve that yourself. So I just want to remind you that when you have a numerical pattern, you can create an input output chart to help you determine the pattern and understand the pattern more deeply. You can also create a numerical expression or a rule using the input chart. And those are our learning targets for today. Also, I wrote a quick summary, and my summary was make a table to look for a pattern. Thank you, and I think it's time for you to try a few problems. And remember, I'll see you at the teacher table. Bye.